Imagine a handgun so revolutionary that it was carried by both sides of World War II. One side emerged victorious, while the other suffered defeat. How could the exact same pistol produce two completely different outcomes? Was the weapon really the deciding factor, or was there something far more important? And how did this legendary handgun shape the evolution of modern pistols for the next century? Let's find out. During the Second World War, a single handgun design found its way into the holsters of both Axis and Allied troops. Long after the war ended, its reach only expanded, eventually serving as the official sidearm for the militaries and police forces of 93 different nations. This mechanical dominance was born out of sheer necessity. Its creator was trapped in a legal corner, and to escape, he had to completely reinvent how a firearm actually functions. In 1914, the French military issued a rigid set of requirements for a new service pistol they called the Grand Rondon, or high yield. It needed to fire a heavy 9mm cartridge, and the entire assembled weapon had to weigh less than a single kilogram, but their strictest demand was ammunition capacity. The French required the gun to hold at least 10 rounds. At the time, that was nearly double what standard military sidearms carried. To meet this highly demanding contract, the Belgian manufacturer for Greek National commissioned the American firearms inventor John Browning. Browning immediately hit a legal wall. Years earlier, he had sold the foundational patents for his highly successful 1911 automatic pistol to Colt. Because of this, he was legally barred from using his own mechanical designs. He could not iterate on his previous success. To win the French contract, Browning had to design an entirely new mechanical platform from the ground up. The first major hurdle was the ammunition capacity. Stacking 10 or more 9mm rounds in a traditional single vertical column creates a physical problem. The magazine becomes so long that the pistol's grip is impossible for a human hand to comfortably hold. Browning's assistant, an FN engineer named Dodon Save, devised a brilliant structural solution, the double-column magazine. As we see in this diagram, Save took the single tall vertical stack of cartridges and pushed outward, staggering them into an interlocking zigzag pattern. This geometry drastically compressed the overall height of the ammunition stack. By widening the magazine slightly, Save's invention allowed an astonishing 16 rounds, later refined to 13, to fit perfectly inside a standard compact grip. The baseline expectation for firearm capacity permanently shifted. Meanwhile, Browning faced his own mechanical roadblock to safely extract and eject a fired cartridge. The barrel and slide need to briefly move backward together before separating. For his earlier pistols, Browning used a vertical toggling link to accomplish this action, but Colt owned that exact pattern. Looking at the schematic of the new design, we can see his workaround. Browning developed a short recoil system where the slide and barrel recoil together, but instead of a toggling link, he placed a hardened steel bar across the frame, sitting beneath a specialized cam slot at the rear of the barrel. As the assembly travels backward, the slot engages the stationary bar, drawing the chamber downward. This angled drop safely unlocks the barrel, allowing the upper slide to continue rearward and eject the empty casing. Removing the toggling link eliminated a fragile moving part, resulting in an operating system that was actually more robust and reliable under rigorous combat conditions. John Browning passed away in 1926, years before the design was finalized. The project's completion fell entirely to Dodon Save. Then in 1928, a crucial legal shift occurred. The original Colt patents expired. With the intellectual property restrictions finals lifted, Save integrated the best features of Browning's unrestricted legacy, such as a removable barrel bushing and a much simpler take-home sequence into the working prototype, finalizing the design in 1934. The resulting pistol, known as the Browning High Power, merged the genius of two master engineers bound together by a simple legal waiting game. Despite initiating the intense research and development process, the French military ultimately decided not to adopt the high power. Instead, it became the official sidearm of the Belgian Armed Forces in 1935. When German forces invaded Belgium in 1940, they orchestrated a hostile takeover of the FN plant. The Axis war machine immediately began producing the high power for their own troops. Designated as the Pistol 640B, it was heavily utilized by specialized German personnel, notably the Waffen-SS and Fallschirmjäger paratroopers. But before the factory fell, the pistol's blue plants were snuggled out and sent across the Atlantic to the John English factory in Canada, allowing the Allied forces to tool up and mass produce the exact same weapons simultaneously. The high power was so mechanically sound that it bypassed geopolitical ideology. Both sides of the deadliest conflict in human history found themselves relying on the exact same sidearm. The design did have physical flaws. The high placement of the hammer often pinched or bit the web of the shooter's hand, and the original French mandate for a magazine disconnect, a plunger pressing firmly against the magazine body, created a heavy, gritty, single-action trigger pull. Yet these quirks were easily eclipsed by the weapon's overall performance. In the post-war era, the high power secured its legacy, serving as the standard-issue sidearm for NATO forces and militaries throughout the British Commonwealth. Save's high capacity, staggered magazine, and Browning's linkless cam locking system laid down a permanent structural foundation for firearm engineering. Today, almost every modern semi-automatic pistol relies heavily on those two innovations. They exist as direct mechanical descendants of the ingenious workarounds forced by John Browning's patent puzzle. The American firearms market in the 1980s was defined by heavy metal. Handguns were built from solid steel or aluminum alloys, and the designs favored established decades-old traditions over rapid innovation. For law enforcement, this meant officers were carrying sidearms that weighed a lot, but usually held a maximum of just 6 rounds of ammunition. Then, in 1986, an Austrian engineer named Gaston Glock brought a radically different design to the United States. He introduced a striker-fired pistol built on a lightweight polymer frame that held an impressive 17 rounds. The initial reaction from the American market was intense skepticism. A plastic gun completely defied the established expectations of what a serious, duty-ready firearm was supposed to look and feel like. This skepticism met the reality of the range. Throughout the late 80s and into the 90s, federal and local agencies put the platform through rigorous endurance trials. The results were staggering. The pistols ran where traditional designs failed, leading to millions of officers adopting the polymer frame as the new professional standard. Glock didn't follow the industry. They gained massive adoption across police departments and civilian markets by solving the core practical problems of reliability and safety. Fast forward to 2026, and Glock is celebrating 40 years in the United States. What began as a small import operation has grown into a massive domestic manufacturing hub in Smyrna, Georgia. But this creates an interesting engineering problem. When your product has been the unquestioned global standard for 4 decades, how do you actually improve it? Upgrading a design built entirely on its reputation for reliability requires a careful balancing act. The hardware has to evolve to meet modern demands without losing the mechanical simplicity that made the platform successful in the first place. That brings us to the Gen 6 line, specifically the G17, G19, and G45 models. Rather than chasing industry fads, the engineers synthesized direct feedback from duty professionals and competitive shooters to inform their design updates. The overarching goal of the new frame geometry is to help the pistol settle naturally into the hands. Shooters shouldn't have to expend extra physical effort fighting the gun's natural movement during recoil. This Gen 6 render shows subtle enhancements, a palm swell, extended beaver tail, and updated RTF6 grip texture. A side thumb rest provides a physical index point. Beneath a deeper undercut allows a higher grip, reducing muzzle rise. Inside, the flat face trigger isolates the finger. Added together, these ergonomic and mechanical updates translate directly to more consistent trigger placement and faster sight tracking during rapid strings of fire. Moving up to the slide, This exploded view shows the Gen 6 optic-ready system. The pocket is mil-deep, allowing the optic to sit lower. 3. Included optic plates act primarily as stabilizers. The mounting screws thread directly into the steel slide for maximum durability by removing unnecessary variables and complex multi-layered mounts. This direct thread system gives the shooter higher confidence that their optic will hold zero under intense physical stress. Ultimately, the Gen 6 design philosophy is straightforward. The pistol doesn't force you to change how you shoot. It simply removes the physical friction so you can shoot better. And all of these modern refinements are layered safely over the original safe action system that built the brand's reputation. This dedication to the user extends past the hardware and into the community. For 35 years, the Glock Sports Shooting Foundation has been organizing matches and building camaraderie for shooters of all ages. That community focus is heavily tied to responsible ownership. Every pistol ships with a cable lock, and the company continually reinforces the 4 cardinal rules of firearm safety. Glock anchors a mass American ecosystem, combining high-precision domestic manufacturing with competitive community growth and strict ingrained standards for safety. Looking past this 40th anniversary, the company's future continues under the guidance of Catherine Glock, carrying forward the founder's original vision. It recontextualizes their famous motto: "Perfection is not a static endpoint to reach. It is a continuous, decades-long process of listening to users, simplifying mechanisms, and refining geometry." The American story of Glock reveals innovation as a relentless promise kept to the people who rely on their sidearms every single day.